Current electricity by Priya. Start.
So first we will see the topic 3, which consists of 15 topics. First is electric current, drift velocity, current density, then mobility, specific resistance and conductance, Ohm's law, limitations of Ohm's law, combination of resistors, temperature dependence of resistivity, electrical energy and power, electric power, then combination of cells, EMF and internal resistance, then Kirchhoff laws and the applications of Kirchhoff. So first will be electric current, which is nothing but the rate of flow of charge through a conductor. I is equal to Q by T. Then current is a tensor quantity. In absence of E external, electrons move in random directions. Then comes drift velocity. In that, we'll be seeing about relaxation time, which defines average time between two successive collisions of electrons as relaxation time, which is represented as tau, mean free path of electrons divided by velocity. So the expression for drift velocity Vd is equal to E by m E into tau.
What is E?
Electrons.
What is Me?
Mass of the electron.
What is capital E?
Electric field.
What is tau?
Relaxation.
What is Vd?
Drift velocity. Then is current density, which is represented as J is equal to I by A. When we expand it, we'll get NEVD. Then we expand that VD, NE square E by M into tau. The unit of current density is ampere meter square inverse. Then mobility.
Ampere
Meter
per meter square. Otherwise, ampere meter power minus 2.
per meter per minus 2. Mobility, which is defined as drift velocity acquired by the charge carriers per unit electric field, which is represented mu is equal to Vd by E. When we expand it, E tau by Me. Actually, this is called mu. You have to put slash and put u. That is mu. Then comes specific resistance, which is nothing but rho is equal to E by J. I have written in terms of electric field and current density. When we expand it, A by L, the unit is ohm meter. Then in specific conductance, sigma is equal to 1 by rho is equal to J by... Rho should be written as like this. This is rho. So J is equal to sigma into E. Unit is ohm inverse meter inverse. Ohm inverse can also be called dash. Mo. No, that is also called dash. O. Sigma. Then comes Ohm's law. Current flowing through the conductor is directly proportional to the potential difference. V is directly proportional to I. To remove that proportionality symbol, we are introducing R resistance. Unit is ohm. For conductor, R is equal to rho L by A. Then limitations of Ohm's law. There are few more examples. For a higher value of current, voltage varies non-linearly. Relation between V and I depends on the sign of V. One of the example is characteristic curve of a diode. That is it. That's all. Next. Combination of resistors in series and parallel connection. So in series, current is a constant. I is equal to I1 is equal to, that is current is constant. In parallel, voltage is constant. V is equal to V1, V2, V3 all are equal. The expression is Rs is equal to R1 plus R2 plus R3. In parallel, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R2. Okay. In case of two resistors, what is Rp? Uh, R R R2 plus R2 Rp divided by R1. R1 R2 divided by R1 plus R. Swap. It is the reciprocal. Take LCM and get the reciprocal. Then temperature dependence of resistivity, rho is equal to rho naught into 1 plus alpha into del T. Alpha is the temperature coefficient of resistivity. Alpha is positive for all metals. Electric energy and power. E is equal to VQ. V is equal to Q. If we expand it, we'll get V square by R into T. So unit is joules for electric energy. Then comes electric power. P is equal to W by T. When we expand it, we'll get V square by R. The unit is watt. Uh, Power dissipated in connecting wires having finite resistance R.
Just a minute. What is this W? What is this W?
Uh, that is work done, sir. This is unit of power. Then power dissipated in connecting wires have finite resistance R, which is equal to PC is equal to P square by V square into RC. So for series combination of R, the value of P is V square by R. In parallel combination, P is equal to I squared R. In combination of cells, series and parallel connection, electromotive force EQ is equal to E1 plus E2 plus E3. In parallel case, we need to divide EQ by R, which is the internal resistance, E1 by R1 plus E2 by R2 plus E3 by R. The another difference is for n identical cells in series connection. Below above above. EQ is equal to n into E. For parallel connections, EQ is equal to E, which is same. Power consumption in combination of bulbs in series means 1 by EQ is equal to 1 by P1 plus 1 by P2. In parallel, EQ is equal to P1 plus P2. So cells, EMF and internal resistance. First come electromotive force E, the potential difference between two positive and negative electrodes and open circuit. That is when no current is flowing through the cells is known as electromotive force. Then terminal potential difference. Potential difference across the terminals of a cell when current is drawn from it. V is equal to IR, which is equal to E minus IR. Internal resistance. R resistance offered by the electrolyte of the cell. E by I minus R. E minus V by V into R, which can be written as E by I minus R. Kirchhoff law consisted of two rules, junction rule and loop rule. First comes junction rule. At any junction, the sum of currents entering the junction is equal to the sum of current leaving the junction, which which can be represented as I plus I4 is equal to, according to the circuit, I've written the uh, equations. I1 plus I4 is equal to I2 plus I3 plus I5. Loop rule, algebraic.
Which are the incoming?
I1 and I4, sir. Oh, sorry,
And I4 outgoing.
out.
These are I2, I3, I5 are incoming.
Loop rule, algebraic sum of potential changes around any closed loop involving resistors and cells is zero. Then come application of Kirchhoff's law. One of its is Wheatstone bridge, which is used to determine the value of unknown resistor, the arrangement of resistors. So the that is the circuit. For that circuit, we can find any one value of the unknown resistance. R1 by R2 is equal to R3 by R4. Then another application for Wheatstone bridge, Wheatstone bridge is meter bridge. It is based on Wheatstone bridge is used to find the value of unknown resistance. R by S is equal to L1 into 100 minus L.
You are not shown the jockey.
Connection
Is
job office.
and that is passed through HR box. So you have to read this.
Yes.
Okay, good. Very good.